Okay, guys, we are going to start on page 6 today, down at the bottom. This is something that we skipped last time. But we ended on this conversation of the idea that when we talk about snowfall, for that last example we were looking at, how does that snow accumulate? Do I get like a bunch all at once, and then another bunch all at once, and then another bunch all at once? Is it gradual? What's going on there? So the last question that we were looking at, again, this is bottom of page 6. I'm going to flip for just a second for you guys, bottom of page 6. The last thing that we were looking at was our snowfall graph, and should we be connecting these points or not? So to decide if we want to connect those points or not, we need to decide whether the variables that we're looking at are what we call discrete or continuous variables. So the idea behind a discrete variable, okay, a discrete variable is that we've got like a limited number of options for values that that variable can take. So we're going to see gaps or interruptions in those values. So one of the options listed here is shoe size. Okay. I could have a shoe size of 7. I could have a shoe size of 8. I could have a shoe size of 7.5. Those are all valid shoe sizes, things I could go to the store and find. Could I have a shoe size of 7.814? That's not an option, right? So I have a lot of options for shoe sizes, and they're not all whole numbers, but every possible number is not an option for a shoe size. There's some jumps there, there's some gaps there. That's what we call a discrete variable. One of the options that I think we talked about at the end of class yesterday was like t-shirts. I can have 5 t-shirts, I can have 6 t-shirts. Can we have 5 3/4 t-shirts? No, I've got the shirt or I don't. Okay. Those are what we call discrete variables. Okay. I've got gaps in those values. I can't have any value for a discrete variable. For a continuous variable, I can have any value. Okay. So one of the options that we see here is time. Okay. Time, something we talked about a little bit yesterday. So when I talk about time, I can have 1 second, I can have 2 seconds, I can have 1.5 seconds, I can go down to milliseconds or nanoseconds. Like my limitation is just the sensitivity of my stopwatch, right? I can have all of those values in between 1 second and 2 seconds. Or if we broaden it to minutes, I can have a minute, I can have a minute and a half, I can have a minute and 7 seconds, I can have a minute and 7.02 seconds, right? I can get as specific as my stopwatch will allow me to get. So that's why time would be a continuous variable. It can be any number, okay, any value. I don't have like hard limits where I'm going to jump between numbers. It can be anything in between the values that I'm working with. So what I would like you guys to do for just a second is think about our conversation yesterday. Think about these ideas and give me a couple of discrete and a couple of continuous variables. Take a minute and think about what would be a discrete variable, what would be a continuous variable. Somebody give me an example of a discrete variable. What'd you come up with? Population, number of people, right? That's got to be discrete. What else? It's another discrete variable. It can only be certain numbers. Can't be anything. It doesn't have to be super serious. Earlier today, we had a very big discussion about whether if a sprinkle breaks, it counts as 2 sprinkles or fractions of sprinkles. Okay, so it doesn't have to be super serious. What'd you say? Sorry. Cars? Okay, yep, cars. Okay. Half a car, not a car. I can't do car things. What else? What's something else that would be a discrete variable? Toes? Sure. If there or if not, right? Something else we talked about earlier today was money. Money is kind of a tricky one because we want to think about money as a continuous variable because I can have decimals for money, right? Your price can be $13.95. That's okay. But can I actually have any value for money? No, I'm limited to pennies, right? I can only go to 2 decimal places. So I actually do have jumps there. Even though we go down to decimals, I still have jumps there. How about some continuous variables? Any value. I can have any value for these things. Inches. So if we're talking about some kind of length or distance, whatever I use to measure it, those are generally going to be continuous variables. We are only limited by the sensitivity of our equipment. So if my ruler only goes to like 1/8 of an inch, I may have to do some estimating if it's not at one of those marks. Volume. What's another one that would be a continuous variable? It could be any value. What did you say? Seconds. So time again. We've got time up here. Yeah, time would be continuous. Speed. Yeah, speed would be continuous. Generally, your car is only going to show you like a whole number, but that doesn't mean that it's not somewhere in between there. Again, we're limited by the sensitivity of the equipment we're using to measure that thing, but it doesn't have to be a whole number. Very good. In one of our earlier classes, we talked about how length or distance is a continuous variable, right? You can run for 2.714 miles. But one of the things that they told me was a discrete variable was if you wear some sort of like a device, like a watch or something that tracks your steps, it's always going to give you a whole number of steps. Okay. So discrete doesn't have to be a whole number. Remember, we talked about shoe size. You can have halves in there. Okay. Doesn't have to be a whole number, but it can't be any value. For continuous, everything has to be fair game, every value. That difference make sense? Okay. So now let's go back to page 7 and let's talk about our snow here for just a second. Now, I wanted to know, my last question yesterday was, should I connect these points or not? Okay. So in order to be able to connect the points on my graph, I need to look at both of the variables that I have, and they both need to be continuous. So my variables are time and the snowfall in inches. Can I connect the points on this graph? Yes, I absolutely can. So are the points on the graph connected? Yes, they're connected. Both time and, let's say, snowfall in inches are continuous variables. as we said yesterday, my snow is accumulating. It might accumulate quickly or it might accumulate slowly, but as it accumulates, I'm getting every option in between 3 and 4 inches, in between 4 and 5 inches, in between 5 and 6 inches. Okay, everything in between the values that I had in my table are values that are possible for those snowfall amounts. And same with time. I looked at the measurements on the hour, but time elapsed in between there. Okay. Questions for me on page 7. Okay. I would like you please to turn to page 8. We're going to look at another example. Number 2, one spring day, Camilla notes the time of the day and the temperature in degrees Fahrenheit. Look, her findings were as follows. At 6 a.m., the temperature was 60 degrees. So I'm going to go ahead and jot down that at 6 a.m., our temperature was 60 degrees. Okay. For the next 4 hours, the temperature rose 2 degrees per hour. So this is a little tricky because I have an increase per hour, but I don't have all those values in my table. So I'm going to keep track of those off to the side. So for the next 4 hours, so we're at 6 a.m., so 7, 8, 9, 10. The next 4 hours, we rose 2 degrees per hour. So I would be at 62, 64, 66, and 68 degrees. I do have 9 a.m. in my table, so I'm going to go ahead and copy that value over. Temperature rose 2 degrees per hour. For the next 2 hours, it rose 3 degrees per hour. So 11 and 12, we're going to go up 3 degrees. That would be 71 and 74. Noon is in my table, so I'm going to go ahead and put that 74 degrees in my table. Okay, that's where I ended. The temperature stayed steady until 6 p.m. So again, I've got gaps in here, but the temperature isn't changing. So for 3 p.m., I know it's still 74 degrees. For 6 p.m., it's still 74 degrees. We stayed steady until 6 p.m. Then for the next 3 hours, so 7, 8, and 9, for the next 3 hours, the temperature dropped 2 degrees per hour. That would be, I was at 74, so 72, 70, 68. So at 9 p.m., we're at 68 degrees. And then the temperature dropped steadily until the temperature was 66 degrees at midnight. So I know the temperature at midnight was 66 degrees. So there's our data. We're looking at time and temperature here. What's our independent variable? Time. Our dependent variable then? The temperature. Let's go ahead and plot our information here. So this is already set up for us. We've got our times labeled down here and our temperatures along the y-axis. Remember, independent is always x, dependent is y. So at 6 a.m., our temperature was 60 degrees. I'm gonna go ahead and plot that. At 9 a.m., so there's 6, 7, 8, 9. There's 9 a.m. right there. At 9 a.m., we were at 66 degrees. At noon, we were at 74, right there. And then our next couple, 3 p.m. and 6 p.m., we're at 74 degrees. So there's noon, 1, 2, 3 p.m. 3 p.m., we are at 74 degrees. 6 p.m., we're at 74 degrees. For 9 p.m., so there's 6, 7, 8, 9 p.m., we're at 68 degrees. That is right here. And then finally at midnight, we're at 66 degrees. And there would be 66 degrees. So I've plotted all my temperatures. The final question I need to ask myself, are the points on this graph connected? Yes, why? They're both discrete, right? They can be any number, right? My time continued on, like I know our table jumped from 9 a.m. or from 6 a.m. to 9 a.m., but we had all the times in between, all the individual like microseconds in between there. And our temperature could be any value in between the ones that we've seen as well. So our graph is connected. Time and temperature are both discrete, or not discrete, continuous. Continuous variables. They're both continuous variables. I'm going to jump up to my graph really quickly and connect those points. If both my variables are continuous, we can connect the points on our graph. Okay. Otherwise, I have to leave them in as sort of like a scatter plot. I would like you now to turn to page 9 and give that problem a try. So I backed off on what I put on here for you for this one. Okay. A drive-in movie theater charges $10 admission per car and $2.50 admission for each person in the car. Assume a maximum of 7 people in the car. Make an input-output table that represents the total cost determined by the number of people in the car. Then graph your data and answer those questions at the bottom. So give this one a try. What are the 2 things I'm keeping track of here? People and cost, right? Which of those is my independent variable? People. Number of people. So then my dependent variable would have to be the cost, right? The amount I have to pay depends on the number of people in the car. I'm going to set this up with my number of people over here on the left and our cost on the right. Now, what kind of numbers make sense for people for this problem? What numbers did you have for number of people? 1 through 7, right? Whole numbers 1 through 7. Why did you not start with 0? Somebody's got to be in the car to go see the movie, right? Okay, so I want whole numbers 1 through 7 here. It told me the most people I could have in the car was 7, so that's why we want to stop at 7. And then it says it's a $10 admission for the car and $2.50 for every person in the car. So if I only have one person in the car, that'd be 10 plus $2.50. So $12.50 there. And then for every person I add another $2.50. So this would be 15. This would be $17.50. For 4 people, that'd cost me $20. Then $22.50. $25 and $27.50. Questions for me so far? Okay, so I've got my table. We know which is the independent and which is the dependent. Remember, independent is always our X and the dependent is going to be our Y. So as I'm looking at setting up my graph, I know number of people is going to go on the X-axis. And then my cost, which will be in dollars, goes on the Y. My spacing for my graph may be different than yours. That's okay. For my number of people, I'm going to label every other one just so my points aren't crammed together, especially as you guys are trying to look at them up on the board. I want to make sure I'm plotting things so that you guys can read it without too much trouble. So I spaced my numbers out a little bit. If you just did 1, 2, 3, 4, 5, 6, 7 all in here, that's okay. Just know your points are going to be close together. And then for cost, I need to evenly space these values, but I also need to make sure I get up to $27.50. So I can't do just by $1, by individual dollars, I should say here. So I'm going to go by 2s. That way I can make sure everything fits on the graph. So this will be 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24, 26, 28, 30. Okay. That'll get all my prices in there. Again, remember when I'm creating a graph, these need to be evenly spaced. Now I'm gonna plot my points. So one person is $12.50, so 10, 12, $12.50 would be just above that. 2 people cost $15, so there's 14, there's 16, we want halfway in between. 3 people cost $17.50, there's 18, so it's going to be right below that. 4 people cost $20, that'd be this right here. 5 people cost $22.50, there's 22, so just above that. 6 people cost $25, so there's 22, 24, 26, halfway between 24 and 26. And 7 people cost $27.50, so there's 28, just under that for $27.50. So there's my points for my table. Last question, do I want to connect these? Why not? These are discrete variables, right? These are my only options for number of people in the car. 1 person, 2, 3, 4, 5, 6, or 7 people. I can't have 2 3/4 people in the car. These are whole number values only. Okay, so I can't connect these because then that would tell me I could have 1.5 people, and that's not okay. The other thing that we talked about earlier, money actually is a discrete variable, right? So the only prices that I would have to pay are the ones that we've listed here. I won't have a car that I charge $21 to. $20 is the cost for 4 people. $22.50 is the cost for 5 people. The in-between values aren't options, right? So are the points connected? No, not connected. Both number of, of people and price are discrete variables. So we want to leave our graph exactly as it is. Those are both discrete variables. Questions for me for today? With our remaining time, I want you to work on the homework assignment that you got last night. Remember, it is due tomorrow.